Welcome, and thank you everyone for joining us for our second webinar in the PGC Users Webinar Series, an introduction to the Polar Geospatial Center, or PGC. My name is Kathleen Torres-Parisian. I'm a PGC User Services staff member in which I provide geospatial support, but I also lead PGC's educational and outreach efforts, such as this. Today, we also have the PGC User Services Lead, Mike Cloutier, and the PGC's Managing Director, Jonathan Punzak. They will help assist answering questions online throughout and at the end of our session. Before we get started, I wanted to share with you some details about viewing the webinar in Zoom. All participants are muted upon entering the webinar. In the Q&A tab, you may submit your questions openly or anonymously throughout the session. Mike and Jonathan will be answering those as they come in, and we can go over any that warrant discussion. We are also going to try to save some time at the end of the session to answer any follow-up questions anyone may have. We'll start with the outline for today. This hour-long webinar is directed for newly funded polar researchers and logistics personnel, recent partners, as well as the general public. We intend to provide a basic but fundamental introduction to our organization, the who, what, hows of our support. First, we will cover background information. This is describing our mission, how we've changed over time, who supports us, who we support and the accompanying roles, and the user services team that interfaces with the public and our users. The majority of today's session, however, will be an overview of our products and services, explaining our public versus restricted data sets, describing our array of ways we can help the polar science community, and showing examples of our support. And lastly, we'll walk you through understanding the first steps of requesting our support. And at the end, we'll have a brief Q&A session with our staff. If you're curious to learn more, our website provides exhaustive information about PGC, our background, our data, services, news, and tutorials. Feel free to check it out at pgc.umn.edu for details and any topics that we do not cover within this hour. Let's get started with what the PGC is. The Polar Geospatial Center is a polar science and logistics support organization at the University of Minnesota, with core funding provided by the National Science Foundation's Office of Polar Programs. However, we do receive other funding from additional agencies, including NASA's Cryosphere program. Our mission is to provide domain and institutional knowledge to solve a broad range of polar geospatial problems, to provide access to sub-meter commercial satellite imagery over the poles and the expertise to task, manage, and process that imagery, as well as produce other high-level value-added products. And lastly, to provide educational courses and online materials to transfer our knowledge and experience to the community. PGC has grown a lot when considering the extent of our geographic support. In 2007, it was first founded as the Antarctic Geospatial Information Center, or AGIC, for support to the U.S. Antarctic program, with only a handful of people. It wasn't until 2010 that we extended our services to the Arctic and became the Polar Geospatial Center we are today. In 2015, we received supplemental NSF funding to launch Arctic DEM, and today in 2020, we have approximately 15 employees, staff, and students, with the rest of the globe's elevation to map as part of our new Earth DEM project. everything happens somewhere, right? So it is to no surprise that PGC has a breadth of users. The general public, Antarctic pilots, geologists, ornithologists, an Arctic cooperative, but this is all within the scope tied to where PGC's funding comes from. As I mentioned, PGC is primarily funded by the National Science Foundation's Office of Polar Programs, or OPP, and the NASA Cryosphere Program. Therefore, as obligations of these federal funds, the makeup of our users we support are also funded by NSF, OPP, and NASA Cryo. We have received other supporting grants from agencies such as the U.S. Fish and Wildlife Services too. So our direct core users are those funded by programs that fund PGC. Fortunately, some of the data we use to support our core users also benefits the public, such as hosting open source data like polar aerial photography and maps, and our high resolution digital elevation models, or DEMs. PGC's role to scientists is essentially all geared to providing geospatial expertise to enable scientific objectives and hopefully to reach them effectively and efficiently. We spend our time processing and manipulating data so researchers can spend their time on their science. PGC's role to logistics contractors and support organizations is essentially all driven to facilitate safe navigation and travel for all parties involved. We map the least mapped regions of the world with polar orbiting satellites, and the implications provide situational awareness, but also reduces programmatic costs by monitoring these sites frequently and remotely. Under the wing of NSF, we share their mission's objective in creating and advancing knowledge. So we aim to transfer what we've learned and experienced to the community. And one way we try doing this is by developing products. So we have imagery mosaics in a web map, or a coordinate converter app, or a browsable online map catalog, all to reach the broadest audience with minimal efforts. We also use educational outreach efforts to meet the community needs. Each year, for instance, we staff an exhibitor booth at AGU. We run an Antarctic logistics workshop in Centennial, Colorado, and attend many other conferences throughout the year. Whether you are a scientist, logistics contractor, or just a polar enthusiast, our entire team works to help our users. Our director, Paul Morin, and managing director, Jonathan Punzak, both work on the next big thing, envisioning PGC's future, while also keeping us on track with current goals. Our data infrastructure team is outstandingly talented and make managing 9 petabytes of data and automating elevation for the entire planet look easy. But it is our user services team that directly interfaces with individuals and groups to provide geospatial solutions to polar problems. So here we are. User services is staffed with 7 full-time staff members and about 3 graduate research assistants. Our team comes from diverse backgrounds and hold really varied domains of expertise, from GIS, remote sensing, earth and atmospheric sciences, and web development. Our breadth of specialists best supports our breadth of users and is why we implement a point of contact system when working with users. So after initial contact with PGC, users are assigned a point of contact, aka a user services team member, to streamline communication and provide the most effective geospatial expertise according to the user's project's needs. Every project is different, but our core activities and primary services are to integrate geographic information into polar initiatives through satellite imagery, maps, terrain models, and even seasonal on-site support at McMurdo Station in Antarctica. Probably our favorite part of the job, or at least it's mine. Before we continue to describe more in depth kind of our products and services that PGC offers, do we have any questions? Is there anything coming through? No. Perfect. So now moving on to a deeper look into how we support our users and the community. PGC's main products and services are best described to fall into these 4 categories: satellite imagery, terrain models, digital maps, and geospatial support. The basis to what we do comes from access to sub-meter commercial satellite imagery from a company called Digital Globe. And with this resource, we are able to help users see and analyze the ground from the comfort of a computer. From stereoscopic imagery, we also produce the foundation: high-resolution digital elevation models, or DEMs, such as Arctic Dam and the Reference Elevation Model of Antarctica, also known as REMA. And thirdly, we design and archive maps for different purposes, including logistics planning, publications, and simply for reference. And lastly, in more challenging problems, we provide geospatial and remote sensing expertise. PGC holds a variety of geospatial data sets made available to the public. So we have maps, aerial photography, and elevation data, including LiDAR, and our stereo-derived digital elevation models across the Arctic and Antarctic. However, a primary service and data set PGC provides to its core users is access to licensed high-resolution commercial satellite imagery collected by Digital Globe. This comes in raw, processed, and even web formats. Other restricted data includes maps that may have formal copyrights, licensed imagery, sensitive information, or just by an authoring organization's request. But again, these are only accessible to our core users, those that are funded by NSF OPP or NASA Cryo. Many of our users are not familiar with commercial satellite imagery or Digital Globe's products at first. So we'll just provide a brief synopsis of Digital Globe specs, and secondly, a basic explanation of the license enabling our access. Thirdly, a description of the value-added processes that PGC offers to those Digital Globe products. And lastly, examples of how PGC and users typically use the imagery. Digital Globe, or DG, is a commercial satellite imagery company founded in 2001 and merged into Maxar Technologies just recently in 2017. DG has 4 active high-resolution satellites with resolutions ranging from 32 centimeters to 2 meters, just depending on the bands. And these satellites take approximately archive enables access to this important resource. The National Geospatial Intelligence Agency, or NGA, has contracted with DG to provide licensed imagery for U.S. government purpose only. Raw, orthorectified, and imagery products are copyrighted. However, this is the good news, derived products such as DEMs or vegetation indices, coastlines, etc., can be freely distributed and are not subject to the license. This comes at no cost to federal agencies and federally funded investigators if their sponsoring agency provides an access point. PGC is that access point to the NSF Polar and NASA Cryo community. Users must only use imagery for the intended project and only while actively funded. I must note that any publications using DG imagery must be pre-approved by NGA. So PGC acts as the liaison between our users and NGA. So please, please, please contact us to coordinate a public release request. PGC offers imagery processing options that really increase the value and effective application of the commercial imagery. Most commonly are terrain and radiometric corrections, like orthorectification or top of atmospheric reflectance. We also offer automated custom orthomosaics and pan sharpening. All of this is within an automated batch environment, so processing one image scene and 1 terabyte of imagery is really no different in our scripts. It's only the processing time that will really vary. So not everybody works in a geographic information system or GIS and wouldn't know what to do with an image file, whether it's orthorectified, pan sharpened, whatever. Yet most of us know how to use web maps like Google Maps. And so PGC provides this really awesome high resolution 50 centimeter panchromatic Arctic, Antarctic, and high mountain Asia orthomosaics. Here's the catch though. PGC user account credentials are required. So this is only available to actively NSF OPP and NASA Cryo funded users. DG's commercial satellites are mission driven, so they collect where there's demand. PGC assembles a tasking plan of locations solicited by the community and coordinates with NGA and DG. So our Arctic tasking submission deadline was just last Friday. If you haven't submitted, please do so. But this will actually go through a deconflicting process before we submit it for collection. A few expectations to keep in mind when you're requesting this imagery. 1, this operation is under DG and NGA's control. PGC does not guarantee collection. We can't control the weather. We can't control current events. This is not our machine. So this also means it is nearly impossible to task collection on a specified day. Even within 3 days is a no-go. Also, limited on-demand tasking and imagery is really only acceptable for search and rescue missions. Once imagery is collected and delivered, many users and PGCers use it for purposes including base maps, classifications between land types, observation and measurement, and several more. So hopefully this brief overview has you really appreciate the use and value of this high resolution data. Before we move on, are there any questions related to commercial imagery products and services? We are cruising. A second major product and service PGC provides are terrain models. Elevation data is central to many science and logistics projects. So we will highlight elevation models created by PGC and those derived by airborne sources and emphasize the free, open, and easy access to these data sets. PGC and partners from other public and private institutions worked to automatically produce high-resolution, high-quality digital surface models using digital globe optical stereo imagery, open source photogrammetric algorithms, and high-performance computing. So the Arctic DEM, the reference elevation model of Antarctica, and soon-to-be Earth DEM of the remaining mid-latitudes offered two distinct products. You have elevation strips. These are overlapping areas of the input stereoscopic images. They're provided at both 2 meter and 8 meter 32-bit geotiffs. All the elevation units are meters and reference to the WGS 84 ellipsoid. So if you are looking at a mean sea level, you will need to convert the geoid. And most importantly, these DEM strips have the timestamps preserved. The other distinct product is the DEM mosaic tile. So these are 100 by 100 kilometer tiles, both at 2 meter and 8 meter resolutions. We also provide resampled versions available at coarser resolutions at 100 meter, 200 meter, and even a kilometer. Basically, these are compiled by using the best quality strips and mosaicing them with co-registration and then feathering between the tiles so it appears seamless. PGC also offers custom DEMs to its core users. You can learn more about these differences between the products and to download the data on our website at pgc.umn.edu. And I should note that the typical elevation errors are less than 1 meter, which is spectacular for regions that haven't been mapped or haven't had elevation at such a high resolution in a long time or ever. Elevation data can be collected in many ways, including airborne laser sensors or LiDAR, or by photogrammetry from aerial photography. The PGC, although we did not and were not involved in data collection, processing, or archiving, we have these original gridded elevation files from these two external polar campaigns available on our server. So one campaign was the NSF Center for Airborne Laser Mapping in 2014 to 2015 that flew for several weeks over certain areas in McMurdo dry valleys of Antarctica. You can see the extent of where they flew on the left side map. Another campaign was the NASA NSF USGS Airborne Thematic Mapper Laser Altimetry System. This was flown back in 2001 over pretty much similar areas across McMurdo Sound, and that their extent is shown in the map on the right. All of our elevation data is freely distributed, even our high-resolution DEMs made from the stereo imagery. Because the elevation data is a derived product and cannot be traced back to the original pixel data, they are not subject to the license. So PGC hosts everything on our public data server and has informational guides about our stereo elevation, frequently asked questions, all of that sort. However, it has been thanks to Esri and NGA to have made our DEM data really easily accessible, interpretable, and viewable in each of their respected online web mapping applications. So you can see here, Esri has their Arctic DEM viewer, as well as a REMA viewer. and NGA has their Arctic DEM web app, as well as an Antarctic or REMA web map. Our website links to each of these applications in the respected elevation tabs. Cool. Hopefully nobody has questions about DEM copyrights, because there are none. Are there any questions about elevation data that we need to answer at this time? Great. So who doesn't love maps? At PGC, we know maps are important to us, not just pretty wall hangings, although we do have a lot here at PGC. We will briefly discuss our map catalog specs, how to access the maps, and what value-added formatting is available, and a glimpse of popular map uses and purposes. Maybe we'll enlighten you and show you how everyone could use a map. The PGC map catalog is searchable online and holds an archive of historical and contemporary polar maps. We have scanned hundreds of paper maps at a very high resolution and provide digital copies. Most have accompanying georeferencing information too, which is crucial in using in a GIS. Restricted and custom maps can be requested only by our core users, again, those that are funded by NSF OPP and NASA Cryo, either through our web form or a point of contact. The majority of our catalog, as you can see in this simple pie chart, contain maps of Antarctica. This may be because we started as an Antarctic support organization. I don't actually know, but we come through with a variety of file formats available. We've got PDFs, JPEGs, TIFFs, which are actually great for high quality printing, full and cropped GeoTIFFs, which are critical for using in a GIS. There are many purposes for maps, which is why they are such a useful tool to so many. Most living in our catalog serve as reference maps, but also for navigation, summary, planning, and index. PGC also provides custom cartography services to our core users. So a significant portion of requests are actually for non-GIS users, such as scientists that need to conduct a field site selection prior to traveling to these remote regions for their field work, or just to detect surface characteristics for safe traverse planning and logistics. We also design maps for publications and presentations. However, again, as I already mentioned, anything with licensed imagery intended for public domain must receive NGA approval. So we serve as that liaison for publications. So just get in touch with us before any public release. This goes along saying that data used in custom maps depends on the audience. Public data is straightforward, has no limitations, but the commercial imagery license agreement prohibits sharing imagery outside of the scope of the award or with the public. So we have usage guidelines on our website, and we just typically address the specifics after receiving a custom map request. Great. Are there any questions regarding PGC's map catalog or custom maps? Cool. So it's difficult to actually capture everything we do into these 4 neat categories. So this last one is kind of a catch-all, but it truly does highlight the several other geospatial support services and efforts PGC offers, including staffing our seasonal office in Antarctica. That always seems to be the most exciting topic for people. So certain groups work in specific data formats, and PGC is able to manipulate data to aid that project management and to homogenize data. So we are able to do a lot of data conversion, working between different data formats, whether different file formats or projections, is kind of like speaking in different languages. So PGC is happy to serve as a translator. The PGC doesn't stop at developing terrain models, though you hear a lot about it. We also provide terrain analysis. So this is often delivering slope or aspect geoprocessing figures. This is really common when groups are hiking from their remote deep field campsite and they're heading to their collection site for rock samples, for instance, and need the least strenuous path. You know, walking in those big red parkas and bunny boots in frigid temperatures is just not the most fun, but I guess they do it for science. PGC is more complex than a geospatial help desk. Hopefully you've gotten that by now, but we definitely provide a lot of advice to users, to partners, and just the general public. If we cannot answer a question, we often know someone who does. So please don't hesitate to ask. We often get questions like, where can I find this data? Or how do I use this tool? What are the capabilities of such? And why are there large offsets or holes or just general problems in a data set? And a lot of effort was put into aggregating our most frequently asked questions and sound advice into building our guide section. So there's an entire section on our website dedicated to providing information to the community and our users about our products and services, but also our methodologies and policies. We even include general knowledge geospatial topics just to help get our users up to speed. There are currently over 30 guides, and it just continues to grow. We cover topics ranging from DEMs, our GitHub tools, and satellite imagery. We hope you'll check it out on the Guides tab on our website to learn more. So the coolest part, literally, of our job at PGC is staffing our Antarctic office. Since 2008, user services staff deployed to McMurdo Station. It's the largest US station on the continent. PGC typically has 1 to 2 people present in the Crary Laboratory from mid-October till late January. So our last team member, Shane, he is packing up the office for the season, maybe as we speak or in a couple hours from now. But he's there because the internet bandwidth is so slow. And it's just more effective to provide an on-site geospatial support to science and logistics groups down there. A lot of our work on the ice, as we say, is custom on-demand mapping, hazard and risk management, site selection and movement planning, distribution of our annual map products, and providing an archive of recent satellite imagery. these high resolution images that I've talked so much about are just really large in size, but they are small in geographic extent. So it wouldn't be possible to say, assist in selecting sites for fieldwork that spans over an Antarctic mountain range from our office in St. Paul. But we are able to bring the most recent imagery collected with us on hard drives and just meet one-on-one with the scientists in McMurdo to help choose their ideal locations. In case we have any researchers planning on deploying to Antarctica now, during the next field season, or just in the future, this slide is for you. So researchers deploying to Antarctica submit these things called support information packages, and we are listed as a service in these forms. So please include us if you know or even suspect you may need our support for the upcoming field season, whether prior to deployment or on the ice. PGC prepares for each field season according to these requests. We reach out to each participant that included us in their support information package to ensure we prepare relevant and useful data. It's just really difficult to satisfy requests without notice because of the bandwidth, but also demand. So heads up. Before we continue, are there any questions about our on-ice support? Perfect. So although deploying to Antarctica is the coolest part of working at PGC, in my opinion, it is absolutely impressive to work with gifted and talented groups and individuals on projects that are improving our understanding of the most remote places on Earth. So these support examples that we'll share with you of Arctic logistics and science and Antarctic logistics and science contributions are a culmination of everything that we've tried to cover today: the who, the why, and the how of our support. We'll begin with an Arctic logistics example involving image processing and machine learning. So the Greenland Traverse for Accumulation and Climate Studies, or as they like to call themselves, Green Tracks, their team came to PGC when planning for their second field season to develop snow accumulation and firn density records. PGC processed 839 satellite images dated from 2009 to 2016, which is about 800 gigabytes of data to cover 70,000 square kilometers. The Green Tracks team used this high resolution satellite imagery in their crevasse detection algorithm and were able to safely map a route across Western Greenland. So you can see at the figure on the left is an example of their results. This clearly shows some of the potential crevassed areas, whereas the source imagery, fortunately I can't show you that because it's copyrighted, but that actually did not depict those areas as noticeably. Here we have an Arctic science and custom DEM example. Researchers from the University of Alaska Fairbanks were tracking movement and retreat of LeConte, or as the local indigenous called it, Hootie Glacier in Alaska. Each year since 2015, PGC generated custom DEMs from stereo satellite imagery over the spring, summer, and fall seasons. The stereo imagery was actually requested during our annual PGC Arctic Imagery Tasking Solicitation, and really made it possible to build this time series over the glacier. A newer research trend PGC is supporting is continental scale science. Between our access to 8 petabytes of high-res imagery and high-performance computers, PGC is expanding small science in a dramatic way. So our example of a pan-Arctic work has researchers from the University of Connecticut conducting Arctic-wide survey of permafrost ice wedges to help researchers understand the spatial and temporal dynamics of this landform. PGC supports this project with image selection, hand sharpening, and delivery. And then their team is using convolutional neural network to automatically delineate the polygons within the imagery. So you can see an example in this left figure here of ice wedge polygons delineated on very high resolution aerial imagery, since again, we can't show the examples on the high resolution commercial imagery without going through those permission channels, but very neat. On the opposite side of the planet is McMurdo Station going through this massive modernization effort, and they're currently under construction. NSF is required to publish a comprehensive environmental evaluations report for these activities to share with the public. So the Antarctic support contractors responsible for administering this report came to PGC for custom map figures to include in their public report. The request had this assortment of map purposes, including reference to the area surrounding McMurdo Station and comparing change from historical imagery, all for public consumption. So PGC used open data sets such as aerial photographs in the different maps. PGC occasionally develops online web mapping interfaces and applications for interactive user-derived GIS. This usually entails a combination of PGC source data sets, like our imagery and elevation layers, and the user's spatial data. So this example here is the ICED, or ICED, is a browsing interface for the Berkeley Geochronology Center's Cosmogenic Nuclide Antarctic Database, and that we helped develop. And as we mentioned in the Arctic examples, a growing trend in PGC support is that growing scale and project scope. So in the Antarctic, researchers from Stony Brook University are counting seabird populations with sub-meter imagery around the entire coast of Antarctica. PGC provides not only the 10,000 plus discrete imagery scenes, but also the computational needs for processing so much data. So this image is just showing the footprint of all of 2017 and 2018 Worldview 3 imagery that we've delivered. PGC has an account system, and this gives our eligible users access to services, restricted data sets, and data deliveries, including that sweet imagery viewer that I mentioned earlier. All of this is available through PGC account. So if you want these products and services, it's worth checking if you are eligible. Which we will help walk you through. So we got you all excited about the beautiful commercial imagery we have, the maps we hold in our online catalog. But if you still aren't sure if you can request our support or download a map, this flow chart is for you. It's basically the first step in determining if you should continue to request our support. So you just answer the questions and follow the answers. Simply, if you are federally funded by NSF OPP or NASA Cryo, you are eligible for our dedicated support. If not, it's okay. We have plenty of awesome open resources available on our website. So we've covered a lot of material today. This is your chance to ask any questions you may have, or feel free to email me at ctorresp@umn.edu. If you have a point of contact, they're there to answer any questions, and of course, simply emailing pgc@umn.edu. Are there any questions? Great. Well, I'd just like to thank everyone so much for attending our webinar and taking the time to getting to know PGC. We hope you have found this session helpful, and please feel free to contact us if you have any questions that do arise. Recording and PDF will be made available via email and online within the coming days. So thank you.